for everyone interested in making the double power supply. That was in my earlier videos on YouTube. This is the definite circuit. Let's look inside. Here we have the wall transformer and another wall transformer. They give 12 volts at 1.6 ampere, but in practice they give 13 volts. And all the voltages on transformers, AC transformers, and then I mean the classical old school transformers have a so-called nominal voltage. That means that when they are indicated for 12 volts, it could be that when you measure the AC it is 13 volts or even somewhat higher. And good quality transformers have a very good core. You see that core? It's made of iron plates. It's so-called mu metal, and it has to be weak iron, and weak iron has to have good properties in losing its magnetism when the field on 50 Hz or 60 Hz in that transformer changes its direction. These are wall transformers made in China, made with bad property iron materials or steel materials, that's a better word, steel. And that means that their output current is related to a certain amount of hum. And that's a problem in this circuit. So the first tip: don't use wall transformers. Buy good quality transformers. They are somewhat more expensive, but they work better, and you don't need an extreme hum suppression. Anyway, two bridge rectifiers and the lamp here. These two lamps are switched directly from the secondary of the AC transformer to the bridge rectifier. And then they are bridged, these lamps are bridged with this switch, both for the positive and the negative lead. And you can bridge that lamp. That lamp is in that case not active. It cannot limit the output current to the bridge rectifier, and of course far more to the circuit that is applied after the bridge rectifier. But anyway, the bridge rectifiers are here. The lamps, the safety, they safeguard the current. You can switch them on and off. And furthermore, there's nothing more to tell. We have here a 2N 3055 and here a tip 2955. The tip 2955 is a PNP transistor, and the 2N 3055 is a NPN power transistor. This is also a power transistor. And when the voltage gets in to the bridge rectifiers, it's smoothed out by a smoothing capacitor, and these capacitors are here on the back side, kind of outboard motor. They are, as indicated, 10,000 microfarad, and that's a quite high value. But the real smoothing effect is realized here with the 3300 microfarad capacitor. And it's important to tell that on these low voltages and high current, all these standard, say, capacitance multipliers don't work. That was my experience. I made many capacitance multipliers in the past. They are on my YouTube channel everywhere. You can find them, but this was the only real solution to get rid of an extreme hum, even on the 10,000 microfarad capacitor. To get rid of that hum, this was the best solution, and this transistor had to have an amplification factor of 70 or 60. And also the tip 2955 PNP must have an amplification factor of 70. And you can test that easily with a transistor tester that tests the current amplification. And it's important to tell that the testing of current amplification for high power transistors is somewhat different compared to the testing the amplification factor of medium power or even small signal transistors. Anyway, that has to be taken in account. This capacitor and that capacitor, this capacitor and that capacitor can be bridged with an 100 nanofarad capacitor and a 470k resistor. I tell here that the front is ECB from that transistor, and I have to study that. It's reversed. Yes, it's reversed. Well, it's reversed here on the panel. Anyway, study the data sheet. It will give you the right information where the collector base and the emitter of this PNP transistor are. That's very important, of course, otherwise it doesn't work. As front, I'm almost sure this is the right pin connections, emitter, collector, base. Yes, that's okay. Anyway, I've mounted here two capacitors of 6.8 microfarad between the collector and the emitter, and I think that they don't play a role. They played a role in my first experiments testing this circuit, but I haven't drawn them in this circuit. So, it's a quite good circuit, it works. I've tested it, the hum is very low. The hum is 5 millivolts to 10 millivolts at the maximum load, and that's approximately 1 ampere or 800 milliampere. But for many circuits with op amps, etc., so no power amplifiers, the hum is not audible. You can't hear any hum, and that's good. So, nothing more to tell about that circuit. Study again the PNP transistor pin connections. They are easily to be found on the World Wide Web. These transformers get quite hot because they are wall transformers. Even when they have no load, the eddy currents here inside the transformer cause heating up of the core. Anyway, no problem, but it's something to take in account, and that's why I have ventilated this box on two sides. And this is the lid. It's also shielded, you can see it. That's perhaps important, also important to tell. This is shielded. It goes here, so. And I have shielded the back side of the power supply with thin plate, very thin plate made from beer cans. And be sure that these beer cans are made of steel. Aluminium is not usable. And also here the back side. So I hope to have a lot of pleasure of this double power supply in the future, and I wish you luck.